make sure you have topology 11 all fired up. Console window should already be up, and you should have already done your pings over to on one of your routers. So a ping to all 255. Pretty easy thing to do. Just ping 255, 255, 255, 255. And just to make sure you have next hop reachability on one of your guys. Ooh. And everyone type in the chat window when you are ready. Okay, looks like we got 1, 2, 3 people ready. Michael, you're still you're privately chatting with me, so just change your chat to everyone. It's on the bottom, send to, and then it's that drop-down box. Okay, so part 2 of beginner EIGRP. You already know how to get EIGRP running on your interfaces. You already know how to get a adjacency up with another EIGRP router. So that's shouldn't be a problem anymore. We'll take a look at stuff like the administrative distance. We'll see what EIGRP beats or loses to. We'll take a look more into the topology table. So there's the neighbor table, the topology table, and then the routing table. We'll see how all that comes into play. We'll do a little bit playing around with the variance, getting the different paths to load balance and load share. I think we changed the hello and hold timers last time, so that's not something that we need to do this meeting. So basically, it's getting traffic to go where we want to in this meeting. We'll take a look at putting the default route in here. So if we want a all zeros route, we'll do that. A little bit different than OSPF, because OSPF we have the default information originate command. Here we do have the same command, but it's a little bit different. We have to do a couple extra things to do that. And let's see what else we'll do. We'll do some summarization. We'll take some of these loopbacks and slam them into a single route. And I think that will probably be it. Then we'll look into, if we have time, we'll look into EIGRP stubs. Okay. So let's begin. We've got your topology up here. We're going to start off something very, very simple. Go on your 2 edge routers, which would be router 2 and router 7, router 2 and router 7, and start a debug IP routing on both of them. So router 2 and router 7. So go over to router 2, debug IP routing, router 7, debug IP routing. Okay, after you do that, really simple stuff. We're going to fire up EIGRP using the Hail Mary command. We're going to throw all of your interfaces into EIGRP. So you learned that last session, router EIGRP, and we'll use EIGRP 100. Put in the no auto command and then the network all zeros. And that's it. That's all you need to do to throw EIGRP on every single interface. As always, you want to do a verification. Your first verification probably should be show IP EIGRP interfaces. That just shows you what interfaces are running EIGRP, so both sending EIGRP and listening to EIGRP. So after that, just go on every single router and type those commands in, or you could, if you're smart, you could paste them in there. And then type in the chat window when you're done. And then what should happen is as you're adding EIGRP on your routers, you should see neighbors start coming up. And in the chat window, I'm looking for 3 people to be ready before I move on. So while we're waiting for that 3rd person to be ready, what you can do is you can go on router 2. You'll see that your debugs have been going. You've been getting routes. Right? Add 10.10.13, add all 1s, that's router 1's loopback. Add all 6s, that's router 6's loopback, all 7s, so on and so forth. Now there's 3 tables we want to look at when you're doing EIGRP. You've got your neighbor table. Actually, this is with most of the routing protocols out there, but they call them a little bit different names. So the first table you want to look at is your neighbor table. If you don't have a neighbor table, you're not talking EIGRP with another router, and that's going to make things a bit tough in getting connectivity. show IP EIGRP neighbors. And hopefully you should see one or more neighbors. We're on router 2, so router 1's on the right-hand side of that guy. Now, if we were to go on router 1 and do the same command, you should see 2 neighbors. So show IP EIGRP neighbors. You have 12.2 and 13.3. That should make sense. Now, if we go to router 3 and show IP EIGRP neighbors, we should see 3 guys, right? One to the left, one on top, and one to the right. So show IP EIGRP neighbors, this is probably one of the first 1 or 2 show commands you're going to do after firing up EIGRP. The information you're going to get from this is you're going to get the next hop IP address, you're going to get the interface that you're going out of, and you're also going to get your hold time, your uptime, all that good stuff. These last 4 numbers you usually don't need to worry about. This Q count, if you see this Q count as anything other than 0, it means things are backing up. So EIGRP, it's sending out updates to the other devices, and for some reason it's not making it to the other side. It's basically staying in your queue, so things are backing up. So, but the 2 things I'm usually concerned about are your address and your outgoing interface. So this address is actually the address of the next guy, of your neighbor. So that's your first table. Your first table is your neighbors table. Your second table is your EIGRP topology table. This is all available routes that are being told to you through EIGRP. This is not necessarily your routes. Okay, these are they could be routes. They probably are, but doesn't necessarily mean that they are 100% of the time. So this is your EIGRP topology, all of the information that you know through EIGRP. So you're on router 3. Let's take a look at this guy right here. We'll see if we can decipher this line. P stands for passive, that's good. Nothing's changed. Nothing's changing. If you see an A for active, that's a bad thing. That means links are down, we're waiting for information, that type of stuff. You'll see the network address, 10.10.12. Okay. In our topology, 10.10.12 is between routers 1 and 2. It's a /24. One successor means we got one path. Feasible distance is the total cost to that guy, the total metric, 3720. Via, that says our next hop is 13.1. 13.1. So that's going to be router 1. We have 2 numbers in this parentheses. The first is the feasible distance. You'll see that this number right here, it's the same number as this guy. And this second number, 28,160, that is what your neighbor is advertising to you, how much it costs. So this is the cost from the neighbor over to that link. So feasible distance is the total. You can think of feasible, F, as in full. It's the full distance. Advertised distance, I think the new Cisco books, instead of calling advertised distance, this is called reported distance, which kind of makes more sense. It's what the neighbor is reporting to you. In the old books, they called it advertised distance. And so what's the problem with calling this the advertised distance? What do those initials possibly could confuse you with? What's another thing in Cisco that has the initials AD? And type your answer in that chat window on the bottom, probably in the bottom right-hand corner of your screen. You can move that chat window around, like I can move it here. So that's one of the cool things about WebEx. You can move these windows everywhere. What's another common acronym? Well, let's take a look. Show IP route. So if we show IP route, this is everything that makes it into a routing table. In our brackets there, what's that first number in the brackets. AD, administrative distance. So administrative distance, initials would be AD. So that's why Cisco wants to get away from using advertised distance, also initials AD, away from EIGRP. So they're trying to change that to reported distance, just so people don't get confused more than they are. All right. So back on router 3, show IP EIGRP topology. This gives you the whole topology. There's a couple things you can add to that. So show IP EIGRP topology question mark. You could type in the prefix if you know it. You can type in active, which is not going to show you anything, but show IP EIGRP topology active. So show me the links that are going nuts. Show me the links that are changing. Now if we pick a prefix, so let's see if we could pick 1111. So you'll put in the mask, show IP EIGRP topology 1.1.1.1/32. You get the details of that guy. So most of the stuff you know, starting from the bottom going up. So hop count is 1. The metrics, the K values that it used, so load, MTU, bandwidth, all that good stuff. Composite metric we know. The first number is the feasible distance. F stands for full, so it's the full distance there. That second one is the reported distance. Internal route means it came from EIGRP only, didn't come from another protocol, it wasn't redistributed. So very good information to have. So this is show IP EIGRP topology 1111, and then the subnet mask. And notice that the subnet mask, they do take a slash there. Okay, so neighbor table, show IP EIGRP neighbor. Your topology table, show IP EIGRP topology, and then finally show IP route. This is your full routing table. And so these are the guys that made it. These are the guys that won. Okay? So far nothing too earth-shattering. What we want to do is we want to pretend that R6 has our connection to the internet. Right, so R6 over here has a connection to our internet, and we're going to pretend that R7 is our internet router. So it's our next hop to the internet. So we're going to pretend that 10.10.67.7 is our connection to the internet, and so we want to be able to tell all of our routers how to get to the internet, because right now if we go on, let's say, the end of our chain, router 2, and we do a show IP route on router 2, got a lot of routes, so that's not a problem. But you'll see that we do not have a default route. So if I try to get to 8.8.8.8, I'm not going to be able to get there. If I try to get to CNN.com, eBay, or whatever, I won't be able to get there. Right? So our first order of business is we are going to take R7 and we're going to make him a DNS server. And the reason we're going to make him a DNS server is so when we ping CNN.com, he's going to answer for us. This is a little bit above and beyond CCNA, what you'll expect in your test, but it's a good thing to know. How many of you guys, and you can type this in your chat window, how many of you guys have DSL or cable modem? DSL, cable modem, or FiOS. You have some type of high-speed internet connection. Okay, so you have a high-speed internet connection at home. Your provider gave you a router. You know, they give you some type of modem or router, and so that guy has the information of the next hop. Right? That's how you get your DNS. That's how you get your IP connection. And here what we're pretending is we are pretending that R7 is your next hop into Fios or cable modem or whatever. Right. So we're going to turn R7 into the world's most expensive DNS server. So go over to R7. So our first order business, we're going to have to make sure that IP domain lookup is not turned off, because this is the favorite thing to turn off when you're doing the Cisco studies. And the reason for that is if you mistype a command, it doesn't go out and search for the DNS name of that command. So show run, type I, and look for the word domain. So right here you see that there is this command, no IP domain lookup. So we're going to change that in just a second, but we should just know that it's there for now. So to change our guy into a DNS server, we're going to take a look. Let's type in the word IP and then question mark. So let's see what we have here. We have IP domain. We have IP domain list, IP domain name. Let's do IP domain dash lookup. So IP domain dash lookup will make it so if we ping cnn.com, we're going to try to resolve it. So type that guy in. And you'll see right here, I'm going to paste you this stuff. I'm going to paste a link to this guy. Hold on for a second. One guy came up with a kind of like a step-by-step into turning your router into a DNS server. Okay, so IP domain lookup, that's going to make it so if you ping cnn.com, it's going to try to look it up. Now, if you try to do it right now, nothing's going to happen. So if you do ping cnn.com on R7, it's going to try to translate it, but you don't have your DNS set up quite yet. So, but we'll get there. So go back into config T. We're going to do IP DNS server. So this will turn DNS server on. Okay, so now we are the DNS server. Now we need to do what's called an A record. An A record translates a name into an IP. So if I type cnn.com, I'm going to be given an IP that I'm actually going to try to hit. So to do that, it's called IP host. Any of you Windows admins out there? You do any Windows Server stuff? This is the same thing as going into Windows, the DNS server, and adding an A record. So IP host, and let's call it cnn.com, question mark, and this is where you type in the IP address. We'll just make up whatever, it doesn't really matter. Alright, so IP host, cnn.com, some funky IP address. You can hit the up arrow, just change the IP address around to something else, and we'll say ebay.com. Now if you end out of there and you ping cnn.com, and you'll see that it's trying to ping to 143.33.2.1, which is the IP I set for that A record. Of course, it's not going to ping back because it's not out there. There's no one actually out there with that IP address. Now, if I wanted these guys to ping successfully, and I'm on R7, exactly, so Mark got it. We could just make a loopback with the same IP address. So go ahead and make 2 extra loopbacks, int loopback 1000, let's say, and give it an IP address of 143.33.2.1. You can make that a /32. And you guessed it, make another loopback and give it the IP address of ebay.com. Alright, so I still have the debug on, so you can see stuff is going crazy. So now if I ping cnn.com, it's going to query myself since I'm the DNS server. I've got a host, IP host setting that says cnn.com equals this IP address, and I've got a loopback set to the same IP address. I'm basically pinging myself, and everyone's happy. So this is sometimes if if you want to statically set an IP address, you wouldn't do it on a Cisco router, but it's a good trick to have. If you're a Windows guy, you guys have a Windows DNS server, so you got that. So as I said, same deal as making an A record in DNS. Okay, anyone having trouble making a DNS server and putting a couple IP host commands in there? Should be pretty easy. And the sole purpose of doing this, once again, is we're pretending that R7 is our ISP. So the router on the right-hand side is our ISP. Okay. So now that we have that out of the way, we have two things we need to do. First of all, we need to get R6 talking to R7. So R6 talking to R7. We also need to have routers 1 through 6, 1, 2, 3, 4, 5, 6, to use, we need to tell them to use R7 as their DNS server. So those are the two things we want to do. So whenever you're faced with a complicated task, just break things down and it becomes much easier. So first of all, just getting connectivity on R6 to R7 and also the rest of our network. We want basic connectivity. We want pings to go through. Now, we could do this. We could make a default route. Right? I could do this. I can make a IP route, all zeros, and then I could point it to R7, which is 10.10.67.7. Right? And then I could show IP route static. And it shows that I have a static route in there, all zeros. It's going out towards 10.10.67.7. So this will send all of my stupid traffic that I don't know about, towards R7, and we hope that R7 can send some stuff back. Oh, that also reminds me. So we have the DNS set up on R7. What kind of route should we probably put on R7 so that any traffic it gets, it will send back towards the left? So we want traffic to go this way. What do we want R7 to do with any traffic it receives? Yeah, we kind of want traffic to also come back. So we probably want to put a default route on R7 coming back to R6. So that's going to be easy. IP route, all zeros, 10.10.67.6. All right, nothing too tough. All right, so we have a default route pointed back. Also, I remember something. We seem to have EIGRP running between R6 and R7. It only creates a loop if we try to go to addresses that aren't in either network. So first order business, we'll get to that, but first order of business is we've got EIGRP running between 6 and 7. And we usually don't want to run EIGRP between a customer and your ISP. Now, if you're doing MPLS or whatever, that's fine, but we got EIGRP running between 6 and 7. You want to cut off EIGRP communication between the two. Now you call up the ISP and the ISP tells you, well, we're not gonna do anything. You can't tell us what to do. We're the ISP. So what command could you do on R6 to cut communication to R7 as far as EIGRP? So if you want to cut communication, you probably want to cut out the hellos. What's a command that will stop hellos going across? Yeah, we could do passive interface. Sounds like a good bet. So before we do passive interface, let's just verify show IP, EIGRP, neighbors. And we do have a neighbor at 67.7, right? So I want to kill that. And just verify that your interface towards router 7 is 0.1. Yep, we could also make sure that network is not in that command. Now we use the Hail Mary command, so to do passive interface, really easy. You go into EIGRP, command is passive interface, and then make sure you type in the right interface, fast01. So you see that the neighbor goes down. We can verify that show IP EIGRP neighbors, and I only see one neighbor. Okay, so we've killed our EIGRP from R6 to R7. That way EIGRP isn't giving us routes that we wouldn't have if we're just customer to ISP. Okay, so we have a default route on R6 pointing to R7, show IP route static. We have a default route on R7 pointing to R6. So Mark asked, does this create a loop? Not necessarily. It is if you ping the wrong address. So if I ping that CNN.com, well, I can't ping CNN.com from R6 just yet. It's going to bomb out. There's a couple reasons why it's bombing out on us. So you can see I'm trying to ping CNN.com. It's not resolving. Now if I go back to R7, show IP host, no. Show IP interface brief. Now we take a look at our loopbacks. I made 143.33 2.1. 143.33 2.1. Now if I ping by IP, I get a success. Alright, so ping by IP works, ping by name does not work. Have any of you ever worked computer help desk before? Computer help desk. So if you've worked help desk before, you know that if someone tells you internet does not work, I can't get to CNN.com, I can't get to the websites, this is one of the first things you do. You ping by name, does it work? No. Then you ping by IP address. Ping all 8s. So it can ping by IP address. This means that our DNS not exactly working. So I have two things at issue here. First issue is we have that no IP domain lookup. This forces R6 to not look at any DNS names. Basically, don't look them up. So we're going to just simply change that IP domain lookup. Okay, that's first piece of the puzzle. Now you'll see that ping CNN.com. Oh, okay, well, I got it. CNN.com. Now, what happened here is, let's see if it got where did it get that name, right? So if we show run, Let's show run. And we have a default route. Okay, that's fine. That gets us connectivity. Doesn't necessarily give us the DNS information. Show IP. See if we could do a show command. Show IP DNS. Statistics. Okay, this probably looks like something we should do on the server itself. Show IP DNS statistics. Let's go over to R7. Show IP DNS statistics. This will probably look a little bit more sexy over here. So we received one DNS request and one DNS response. We sent out a reply. The forwarder and all that stuff, that's if we hand it off to another DNS server. Okay, going back to R6. Let's see if we can set the DNS server to something. Now this is different than R7. R7, we made him into the DNS server. R6, all we're doing is we're pointing him to someone else. Okay, we're pointing him to look up DNS somewhere else. Okay, so let's see if we can find the command for that. Now you would think it would start with DNS, but it doesn't. And does it start with domain? It doesn't. So it probably starts with something like IP, right? So we'll do IP. And we did this on the other guy. There's IP domain lookup, IP domain list, there's IP domain, all this good stuff. So let's see, IP DNS. Now IP DNS server, just like the other guy, turns it into a server. Ooh, IP DNS primary, that's your domain name. So this is like, oh, SOA, yeah, we don't want to get into that. Okay, so IP DNS is more like if you're going to set this, you're doing server type stuff. Okay, IP domain, you've probably never done this before. IP domain is if you run and you want to call you want to put your routers like r6.pandarg.com, r7.pandarg.com. They're all hooked into Active Directory and DNS. You want to be able to automatically ping R6 and it adds in the pandarg.com in there. So this is what we do here at Panda Restaurant Group, and a lot of other places do that. So that's your default DNS name that it's going to add in there. Okay, IP domain lookup, we know it forces domain lookup. IP domain lookup source interface, that just tells the DNS server where you're coming from. Usually you don't need that. Alright, so IP domain question mark. We got some round robin stuff, we got list and all that stuff. Right? So you can see a lot of options that can get you into trouble. And is everyone caught up with us? Okay. Now if you did IP and you did a question mark, past DNS you'll see N, and you'll see this command right here. Nameserver. Specify the address of nameserver to use. So you'd think it'd be under the whole DNS and domain, kind of in that section, but it's kind of far down there. So let's see. IP nameserver, question mark, asks you for the IP address of the nameserver. So let's see what happens if we set it to the wrong one. So that's definitely not the IP address of the name server. So if I ping cnn.com, it's now sending your DNS request to 9.9.9.9, and it's bombing out on us. Now let's see what happens if we set the DNS to the correct guy. It's going to be 10, 10, 67, 7. And ping cnn.com. Oh. Now you see it's bombing out on me, and here's the reason. You can have multiple DNS servers. Oh, and it finally reached the second one. We don't actually want that to happen. So if you show run, you'll see that I've got two name servers. You can actually have multiple ones. So check the first one, it bombed out, and then it checked the second one. That's just like in Windows. Windows, you could have multiple DNS servers. A primary and a backup, usually. So what we want to do is let's get rid of that old one, so no IP name server 9999, or whatever IP address you typed in. And so now if you ping something like ebay.com, it should come back pretty quickly. So all that's happening here is you have configured R6, and you said IP name server, go ask R7 if you get a DNS name. R7 should reply back with the IP address, and then you use the IP address to get out to the internet and wherever. Right, so first you want to ping that name, ping ebay.com. You don't know the IP address. You're going to ask someone else for it, and that someone is the DNS server. And you can get there because you have a default route going out. Right, so two things are happening here. DNS is working correctly, and your connectivity, your network, is working correctly. Okay, so that's R6. If we want to get this to work on R5, if I want to be able to ping cnn.com and ebay.com on R5, could I put, let's say, a default route over there pointing towards R6? Would that work for my connectivity? So if I were being paid by the hour, could I go on R5, put a default route towards R6, go on R4, put a default route towards R5, R3, R1, so on and so forth. Just go down the chain and keep pointing the default route to the router on the right. It would work, yes, and I would probably get paid a lot of money because you're getting paid per the hour, but it's not exactly the smartest thing to do. So life would be kind of interesting here. So we don't want that to happen. So let's think of a better way. In EIGRP, we have something, EIGRP and RIP, we have a couple ways we could do this. We already have a default route pointing out towards, on R6 we have a default route pointing out. We have something in EIGRP called summary address, and we could go on an interface like fast00 on R6, and we can send out a 000 route. And what this will do is this will send a default route out towards R5, and this is going to send it in EIGRP, so it's going to basically go down the line and say, oh, okay, well, if you want a default route, you're going towards R6. So it's a one-shot deal. You do it in EIGRP, you do it on the front router, your exit router, if you will, and that's going to chuck it all the way down to R2. Very simple and easy command. So let's do this. It's going to be R6 fast 00. And so it's going to be IP summary address EIGRP. Make sure you type in the right EIGRP AS number, 100. Could be something you may see in your test. Get something saying, oh, well, we're not getting that to the internet. Why is that? Well, it could be something as simple as they typed in EIGRP 1 and you actually have EIGRP 100. So IP, summary address, EIGRP 100. And the address that you type in here is the address that you're going to give the routers to the left. So all the routers down the line, downstream. So we're going to just put in all zeros, all zeros. Okay. Now you have the debugs turned on R2, right? So just hit enter a couple times just to give yourself a little space. Go back on R6, hit enter, wait a second or two, R2 lights up, and all this stuff happens on R2. So let's see what happened here. Well, look at this. It deleted your route to R6's loopback. It deleted the route between R6 and R7, 10.10.67. Right? So delete this, delete that, delete. I don't see any adds other than it added a default route, add 0000, and it's telling you hit R1 to get there. Right? So if we show IP route, EIGRP, pipe I, and then D, you're going to get a nice listing of routes that you learned through EIGRP. You'll see that you've got all the loopbacks. You got the loopback for router 1, you've got the loopback for router 3. The reason you don't see all 2s in there is because it's connected, so it's in your routing table. You didn't actually get that through EIGRP. So you see loopback for 3, loopback for 4, loopback for 5. You aren't getting a loopback to 6 anymore. And the reason is when you made the default route, it killed everything else coming from R6, and it just replaced it with the default route. Because you really don't need to know how to get to that default, the loopback precisely. The default route gets you towards the loopback anyways, so Cisco says, you don't really need that extra junk. We'll just take care of it. Okay. So be very careful in your test. They may ask you this. They may give you a scenario where you show IP route, and you're looking at this topology and you're missing a loopback. You're missing a loopback. And they could ask you why is that loopback not in there? Well, it could be. Maybe you're advertising a all zero summary route from that particular router. And then it kills everything else that router is sending you. Now, just because all 6s is not in your routing table doesn't mean you can't hit it, because you still have an all zeros route. Right? So you should be able to still get there. Right? So the all zeros route gets you to that R6 loopback. And every router to the left of R6 should have a default route. Right, that default route's going to be, oh, I killed it. Default route's going to be through the bottom. It's given to you by EIGRP. And you can see all the next hops are set to the router on the right-hand side. Right? Any questions about the summary address command? Summary address command. You're advertising it on R6. You're putting it on R6's fast00. And effectively what's happening is from here, you're sending a default route information. It doesn't have to be a default route. It can be anything that you actually, that is a subset or superset of what you already have. You have to actually have some of those routes in your routing table. And it's sending it off to the left. So that's not the only way we could do it. But first, before we get into that point, let's see if, let's say you're the admin over here on R3. You're the admin on R3. You're getting this default route, which is fine. That's cool. It's good that you're getting that default route. But let's say you don't want anyone to the left of you to get it. Right? So you yourself, you want this default route, but you don't want R1 and R2 to get it. Now the regular behavior is R1 and R2 are going to get it because this is all happening through EIGRP. Right. So let's see if there's a command on R3 that we could do to stop R1 and R2 from getting that default information. Right. So we don't want those last two routers to get that information. Okay, so go on to R3. And just verify show IP route all zeros. Right, so we are getting right here, are getting that. So if we go into EIGRP and we do a question mark, you'll see this default information. Now there was a default information in OSPF. That means we give out the all zeros route. Let's see what this one will do. So default information. Now look at this. Accept it inbound, outbound, allow it. So let's see if we can control it outbound. So let's see if I put the word out. Oh, we got an access list. Ooh, look at that. Or we can just hit enter, right? Let's see what happens if we hit enter. Well, we have our debugs working on R2, so that's good. Hit enter a couple times. And we're on R3. So default information out. I think that will allow it. We probably won't have any changes in there. Okay. So now, no default information out. Let's see if that will do anything. Okay. So we're on R3. Let's take a look at R1. We probably should have started a debug on R1 as well. Oh, looks like we're still getting it. Yeah, we're still getting the debug, or still getting the all zeros route from R3. Yep. This counter's incrementing, so we're still okay. Now even if we clear, let's see what happens if we clear IP EIGRP neighbors. We just kicked over EIGRP on R1. Lots of stuff is happening. Oh, yeah, look at that. We're still getting that default route in there. Right? So maybe that's not the correct command to use. Go back to R5 or R3. Show run. Pipe B router EIGRP. See what we typed in there. No default information out. So didn't exactly work like we thought it would work. So let's go on router 1. Let's see if there's something that we could stop stuff from coming in. Router EIGRP 100. And so there was this default information allowed in. Okay, so default information allowed in. Let's see what happens if we do no. Now if this works, then what I could do, what it kind of looks like I could do, is I could go in R3 and do like no default information allowed out. But first of all, we just have to see if this one works. So let's wait a little bit. You can also clear IP EIGRP neighbors to kick it over. And so before I was getting this this default being refreshed every so often. So let's see if I show IP route. Let's see what's in my routing table. Whoop, looks like I'm still getting it. Wait for all that to clear out. And show IP route, and it'll probably still be in there. Alright, so in situations like this where you think the command is supposed to do what you're thinking it should be doing, so the command that we think should work, no default information allowed in. So there's two possibilities here. Either we're screwing up on R1, or maybe we're not actually getting a real default information, a real default route in. Because remember, on R6, the way we're getting this all zeros route is with the summary address. Right? So if you show run interface fast 00, the way you're putting in that all zeros route is this summary address information. Let's see if we can introduce a default route a different way. So a default route a different way. There's a couple ways we could do this. So first of all, let's take out that summary address. Should be able to just hit the up arrow, put a no in front of that. So as soon as you take out that summary address, if you look at R2, that network should be gone now. It says delete this, so that's good. Go on to R3, show IP route, that should be gone. Yep, default route is gone. So let's see if there's a different way of putting in an all zeros route. Let's see if we can do it in EIGRP. Okay, so if we do a network all zeros command, that doesn't necessarily mean that we're chucking all zeros over. So all that means is we're throwing all of our interfaces into EIGRP. Okay. So if you do a question mark, nothing really here that might help us. Maybe it doesn't start with default. Default network. Let's see if this does something. Now default network, if we look over here, doesn't exactly tell you what to type in, but let's type in 10, 10, 67, 0. Show IP route. Okay, we have this, but I think this is probably from our IP route statement before. Let's see if anything changed on R5's perspective. I didn't really change anything going over there. So go back to R6. Router EIGRP 100. Hit the up arrow, kill that last command. All right. Looks like it didn't even take. Let's try another command. Starts with IP, and if you do a question mark, there's the default network command. Default network command. Let's give that a shot. IP default network. IP address of the default network, 10.10.67.0. And all we can type in there is just an enter right there. All right, let's see if anything happened. End out of there. Your local route is probably going to be the same. You've got we still have our all zeros route in there. R5 is probably going to be the same here. Let's see. Yep. And because that's going to be a little tricky with this guy. If we show IP interface brief, there's a little trick to this command. So we do have the correct network, 10.10.67.0. Show run interface fast01. We have it in a /24. But if you look up in Cisco's wonderful website, let's see if I can look this up here. Let's go to actual Cisco. Okay, configuring gateway of last resort using IP commands. Default network. Okay, blah, blah, blah. I'll paste this into your chat window. Okay, so default network, so they're putting in here default network 171.70.00. Notice that there is no mask after that. Right, so there's no mask. In Cisco commands, generally when you see stuff that doesn't have any mask, what does that usually mean? or what could it mean? Okay, so Michael Smith says probably classful. Okay, so if we think it's classful, so we're trying to type in so we tried to type in 10.10.67.0, and you show run, and you're trying to find that command. Alright. You're going, I for sure typed in that default network, it's not in there. So if we're thinking it's a classful, here's what we're going to do. If you show run interface fast00, you'll see that we have our interfaces set as a /24. Well, we have other default stuff going on. So what we could do on R6 is we can clear out, we have some old configs that we probably need to get rid of. So clear out your all zeros route and clear out any other static routes that you may have. Alright, so you cleared out everything. Just do quick verification, show run. Oh. That's probably it right there. It's not letting me get rid of it. Oh, it's stuck. Okay, so now I've cleared out that all zeros route. I'm going to do a IP default network 10.10.67.0. And you can see it bombs out on me. So let's try this. If we think it's classful, we're going to go into interface fast01. Instead of making it a /24, let's change this IP address around. Let's change it into a /8. So 10.10.67.6, that part stays the same, but we're just going to make it a /8. Oh, we have an overlap. Oh, we're gonna have to do some major surgery here. That's okay. We're going to go into interface fast00, make that a /8. So that guy's going to be 56.6. Yeah, we're going to have to change one of these. We're going to zero out. So we have a chicken and egg scenario. We can't change one without changing the other. So I'm going to show you a trick. Default interface fast01. That's going to wipe out the information on fast01. And now we can change fast00. So fast00 is going to be 10, 10, 56, 6. Make that a /8. And we go back to fast01, IP address 10, 10, 67, 6, /8. Oh yeah, this is going to be, see, /8, as long as it starts with a 10, it's not going to let us put that in there. Right? But that's okay. Watch this. So we have this interface here, 10, 10, 56, 6. Let's see what happens if now we do our IP default network, and we're just going to put it the wrong way. But that's fine. And start it with a 10. And if you need to change your duplex settings, that's fine too. Right. Yeah, that's probably an easier way is change a loop back to a /8 rather than actually changing our real IP addresses. I'll go with that. All right, change your fast00 back to normal. We're thinking a little bit too complicated here. Ten, 10, 67, 6. Back to normal on those interfaces. Yeah, you're good. And we'll change our loopback here, interface loopback 10. IP address, let's do 101.0.0.1. Make sure we don't have any lingering configuration. Oh yeah, so used to typing in a /24. Yep. $10,001. And that's not going to work because we have a 10. 11. So the problem with the /8s, they match with a lot of stuff. So show IP int br. Probably have a whole bunch of loopbacks in there. No int loopback 100. No int loopback 10. There you go. So now you have a loopback. You still have your good interfaces. 10, 10, 56, 6. That's to router 5. 10, 10, 67, 6. That's to router 7. You still have your normal loopback, loopback 0. That's all 6s /32. And you've got your loopback, whatever you called it. Mine, it's loopback 101. This is a real /8. It starts with 11. It's not a fake /8. We also made the mask a /8 as well. So everything matches. It's going to be class A. Show run. So you can see this default network command. Lots of stuff has to be happening for you to get this to work. Okay, we have a default network in there. And we just have to kill that guy. So no IP default network 10.0.0.0 and change it to the new one. In my case, it's 11.0.0.0. So we do this command on R6. Okay, nothing too spectacular there. You see we have a little star here. So it says in my case, it's connected. We got a star, candidate default. Loopback 101. Let's take a look on the router to my left, R5. First we make sure we have our neighbor up, show IP EIGRP neighbors. We do have a neighbor at router 6, so that's good. Show IP route. And finally you can see, after all that, that guy right there, your last line, gateway of last resort, that's at the top, 10.10.56.6, is going to network 11, which is the loopback on router 6. That's being advertised through EIGRP. Let's see if it goes down the line. Go to R4. So it is going down the line right there, gateway of last resort. Going down the line. Show IP route on router 3. Gateway of last resort as well over on router 3. And let's go all the way to the end on router 2. Show IP route. Okay, so it didn't make it to router 2, which is all the way to the end. Gateway of last resort is not set. Did get an 11 route. Show IP route 11.0.0.0. Yeah, the filtering's still on. So we got this 11 route through normal EIGRP. If we go to R3, show run, I bet you we still have our filtering on. Boom. No default information out. So default information made it, that all zeros route made it to R3, and then it got killed going out. So what do you guys think will happen if I take this line out? So if I do default information out on router 3, what am I going to get on router 1 and 2? So what will I get on routers 1 and 2 if I take out this no default information out? Well, you can see if I go on router 2 and router 1, gateway of last resort is not set. Right? No stars or anything like that. R1 says the same thing. If I go on R3, router EIGRP 100, default information out. Let it sink in for a little bit. Clear IP EIGRP neighbors. Okay, and we'll make sure that we don't have any default information filtering coming inbound, because I think we did that earlier. You can see how sometimes our configuration is kind of messy. Okay, I think we took it off there. Show IP route. Still dying going out. Okay, router EIGRP 100, network all zeros, null auto summary. That looks pretty decent. Yeah, somewhere. Oh, look at that. Show run. Filtering somewhere. Yeah, there we go. That's a clue right there. It's on R1. Take that guy out. Default information in. Show IP route. May have to clear it. Wait a little bit. And the last deal in my line here, in all these dozens of routing updates, new default information, and right there the update comes in. Show IP route. Gateway of last resort, we got it. And this was a combination. We had default filtering going everywhere, inbound and outbound. And after I took all that out, it came in. And we get this wonderful star. We go to R2, and we should see the same thing. Right. So if you're doing that default network, that's the guy that gets you a real default route. You can see it's classful. It was pretty ugly for us to get it. You have to be a real /8. So it's not as quick and dirty as OSPF, where you just go on the router at the edge, default information originate always, and then it chucks in a default route. And these are the wonderful things that in CCNA world doesn't seem that big of a deal, but this is stuff that they could really hurt you with in CCIE, where you're typing in this command and you think it's not working, and there's just landmines everywhere. Okay. So now that we know that those filtering options were working, so we know we're getting a default route on 1 and 2. So now if we do a default information, if we filter it outbound, it should work. So R3, no default information, let's see, allowed out. So let's see if that works. No default information allowed out. Kill that guy. Actually, R1 is my next hop. Oh. So got it. So no default information allowed out. That apparently no default information out. Let's give that a shot. Show IP route 11.0.0.0. Still coming from R3. Kicked over both sides. Okay, that seems okay, so that's good. We're going to always get this 11 route because that's being learned through EIGRP. What we're not getting is a gateway of last resort, so that is definitely working. Now, if you're not careful, you look at this 11 and say, gosh darn it, we're still getting it, but This is just a route to 11. This is not a default route. So that's how it looks now. Just to verify, if we go to R3 again, you undo your last command. Clear IP EIGRP neighbors. And you are getting 11, but it says new default network. So this is reproducible. We can flip it, and we know exactly what the change will do. Right? So definitely a little bit extra work that we had to do, but that's what you're going to run into when you're doing the IP default network and playing around with the default information originate. Okay. So remember, the default information originate command in EIGRP, what we were typing in, default information originate. In OSPF, this makes the default route on your router and sends it to everyone. It's basically saying, everyone come to me. That's an OSPF. In EIGRP, what you're saying is, I'm getting a default route. Do I want to give it out? Do I want to take the default route? How will it be passed downstream from me? So this means you're getting a default route from someone else. How do you choose to propagate that? Do you propagate it? Do you let it through? Do you accept it? Like from R5 to R3, do you accept it but not give it to R1? That's what this default information originate command does in EIGRP. Completely different than OSPF. And you saw that today, So here with this command, we're able to kill the default route, the EIGRP default route, from getting to R1. So we could either kill it outbound, going out to R1, or we could kill it inbound. So R1 kills it from coming in. All right. And one last thing before we sign off. If we go to R2, let's do some summarization. See what loopbacks we have on R2. So R2, we've got our 4 loopbacks: 98.1, 101, 111, 121, 131. So we got 4 loopbacks. That third octet, we could probably combine them. So instead of sending out 4 routes, we want to send out 1 route. So if I go on R5, let's say, and I show IP route, EIGRP pipe ID. So let's see what we got here. $99.99. Oh, that was R2. 98s. Okay. So 98.101. So we're looking for 98s. Yeah, so right here. 98.100, 98.111, or 110, 120, 130. So we got 4 entries for those loopbacks. We don't necessarily need 4 entries. We just want 1 entry to get there. right? So we could do that with summarization. Now, before we did summarization, we did a pretty extreme example. We said IP summary address all zeros. That just means like take everything and scrunch it down to all zeros. That's kind of extreme, but sometimes it's a nice thing to do. Here what we want to do is we want to change these four. So 98, 100, it's hard to read, sorry. 110, 98, 120, and 98, 130, right? So I take those three and slam them down into one. And we could actually do that. We could go on R2. And the summary address is going to be done on the interface pointing outwards towards the routers that you want to send this address to. So this is done on the link towards R1, interface fast 00. IP summary address, you did that before, EIGRP 100, make sure you're in the right AS number. And this is going to be easy. The first two octets match, 98 and a 1, right? So nothing there changes. Now we want something that's going to match a 0, a 1, a 2, and a 3. Now the router actually sees this instead of decimal, it sees it as binary. And if we were to type this out in binary, let's bring up our wonderful Notepad++. 1, 2, 3. Okay, so those are the four numbers we're dealing with. Binary we know is 8 digits. And I divide the digits, I put a space in between four of them, the fourth one and the fifth one, just to make it easier to read. Okay, so the binary for 1, that's going to be easy. It's all zeros and a 1. Binary for a 2, and binary for a 3 should look like that. All right. So that's the third octet. We know the first octet's 98, that matches. The second octet is 1, that matches. We just have a question about that third octet. Right? So how many places match in that third octet? If you're counting from the left. 6, right? So the first column, second column, third column, all the way to 6 columns, all those are the same. So figuring out the mask for this summary is pretty easy because, well, the first two octets give you 255, 255, that's 8 and 8, that's 16. And if your first 6 match, so your first 6 are that, well, you just take 8 plus 8 plus 6. So 16 plus 6, that makes it a /22. So you're counting from the left. Okay. So we're going to say 98.1.0.0. Network mask, well, it's 255, 255. Now you're matching the first 6. Now you could do it the long way. Everyone's made this table before. 128, 64, 32. Right? You could do it that way. You could count from the left. You could use Windows Calculator. Right? And for those of you who don't know how to do this in Windows Calculator, where are you, Windows Calculator? What? Oh, it's in behind my WebEx window. Hold on. There we go. Okay. Can everyone still see my screen? Hopefully. Because calculator has this shared text on it. I'm just wondering if it's only calculator shared or if it's everything else. Okay, cool. Okay, so in calculator, Windows calculator, you can go to programmer mode. And programmer mode, you could decide between decimal, hexadecimal, all that stuff. Right? So if you do something like you go into binary and you do something like 1, 0, 0, 0, 1, 2, 3, 4. So 1 followed by 7 zeros. And then you click on decimal, it's going to change it to the appropriate decimal format, 128. So if you didn't know what mask to put for the first 6s, what you could do is this. You could do 1, 2, 3, 4, 5, 6, 1, 2. Right, so 1's in the first 6 spots in 0, 0. Click on decimal, and you got 252. Now those of you who do a lot of ISP stuff, you'll know the 252 mask a lot because a lot of times you're doing connections with just 2 computers, and that's usually like a /30 mask. Right? So everything's the same except the last 2 spots. Okay, so 252.0. You can give it a different administrative distance if you want, but normally you could just hit enter there. And so now you've summarized this, and if we go to R5, let's see, hit the up arrow, show IP route, EIGRP, pipe ID, you'll see that now those 498s that you got before, so before you got these, 98, 10, 11, 12, 13, before that's what you got. And now you have 98.1.0.0. Now if we show IP route, just for that guy, show IP route 98.1.0.0, you see it's a /22, so that makes sense. Right, gives you some information. Now we should still be able to ping 98.101, 111, 121, and 131. So it took all of those, slammed them down into one advertisement, one network, and that happens down the line. Right? Was everyone able to get that summary to work? So you should be able to go on any router down the line to the right and see that summary. Everything except which router. R7. And the reason you don't see it on R7 is because we cut the EIGRP connection between R6 and R7. That was through the passive interface command. All right. So that was pretty good. We did some summary address. We did the default information originate, the IP default network. We spent way too much time on that IP default network, but I think that's good. You got to see me flail around a little bit. So that's a /8. That's the thing that's going to kill you on that guy. So not too shabby. And we got to talk about the EIGRP neighbor table, the topology table, and then your routing table. So the three things you need to see to kind of put all this together. Threw in a little bit of a passive interface on that guy, so that was good. So not too bad of a session. Any final questions before we log out of here? This, as a reminder, this will be the last beginner meetup that I'll be running for the next 2 months, 2.5 months, doing my little international disappearing act once again. Basically dropping off the grid for 2.5 months. And just for posterity's sake, so people on YouTube can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have decent amount of participants in our WebEx here. This is our free WebEx training. This is the chat window. Not too bad. All right, well, that's it. Thanks for attending. And this will be thrown on YouTube. I'm going to render this and throw it on YouTube. Should appear up in about 3 to 4 hours. Now we have to make a decision about WebEx. Email the list on whether you like the WebEx or not, because it's going to cost me money. It's like the 25 user version. It's like $50 a month. Not a big deal, but just let me know if you like it, and I will see you in about 2.5 months. The beginner people, the experts will probably still do stuff. So, okay, we are out of here. Thanks for attending.